coming. Good afternoon. It is actually okay that this is a post-lunch session because in truth is not really technical at all, so it should be easy to get by. The reason for that is that I'm basically here to tell you a story. Let's say a quick retrospective about what it meant for us as an organization to go through the conception, development, rollout, and adoption of a set of big data solutions, right? Because of this, we'll go through a series of topics that are very diverse. We'll touch on lean, we'll touch on product management, we'll touch on technology and somehow DevOps, and how all these different aspects of modern application and service development interact with one another. And in truth, this is because the second headline of this presentation might as well be this. That means how do we change the pace between doing sustainable development, boring development maybe in a sense, and achieve innovation in certain areas that aren't being covered by traditional mechanisms, right? So let's start with the usual introductions, who I am, what I do, stuff like that. I'm Francesco. Not a lot of work went into this slide, arguably. I'm an engineering director, and I've been working in the fintech ecosystem for quite a while now, tradition around risk, fraud, and credit card schemes, and more recently about crypto, blockchain, Bitcoin, stuff like that. I'm a data enthusiast in the sense that I make it part of my daily job, in a sense, to help and educate others in how to be making better use of data and quantitative analysis to support their own decision making. I work for a company called The Workshop. This is the only monospace font you'll see today in this slide deck. We are an independent technology platform, service provider that serve a global array of gaming and fintech operators. That means that we don't just build software, bespoke software on behalf of our clients, but we help them through the process of operating and marketing their products and brands. I'm the proud leader of a department called the Workbench that focuses on building cool gaming platforms, most of all. Let's start with what the story is actually, right? So the story begins with me joining this company 6 years ago now, I think. And I'm sure it happens to many of you when you get to a new place. There's a time during which you start looking at things and wondering why they're done in a certain way. Certain things might look backwards. Certain things you might just want to do differently. And after some time, you might have your own explanations, but you have to get that extra step and understanding what the context around that situation is, right? And for me, this story is actually me scratching one of these itches, right? So there's 3 reasons why I picked this specific example, this specific story for this pitch. And one is, the first one is because it's interesting enough to be meaningful. The second one is because it's at the same time small enough that it can be managed in a session like this without getting lost in the details. And the third one is because there's a bit of a hype to it in the market, in the industry right now. This is not a sales pitch by any means, so I'm not trying to sell anything, just what we went through, just in case you were wondering. So the context around this story is e-commerce fraud, because my background, that's what I do, or what I've done in the past. And just to give a bit of context around what it means, for those of you that might know the term, although it's pretty mainstream nowadays. Truth is that e-commerce fraud is especially relevant for those merchants that accept payments for virtual goods. And that's because there's usually no established or no predictable chain of trust between an individual or an entity that purchases these goods online, and on the other end, the merchant that accepts money in exchange for these goods. And e-commerce per se is a pretty large industry. Like, I think it's a $1 trillion industry nowadays. And of course, when there's a lot of money being thrown into something, there's all different sorts of conflicting interests showing up. We can classify e-commerce fraud as a promise-based in many different ways. There's no standard, so to say. So this is my own classification in a sense. So the first example of e-commerce fraud might be identity theft, right? Every year by now you have at least one of these very large internet operators like Yahoo or LinkedIn that get their own account database is compromised, and as a result of that, there's a pretty thriving market of stolen identities right out there that people can purchase for all sorts of illegal activities. One of them is purchasing things online. This is not about just the fact that an account is stolen and it can be used on that same operator side. It's also because it's very easy to infer sometimes credentials that belong to the same identity but on different operators or brands. The second category here could be friendly fraud, which might be a bit of an oxymoron, right? There's nothing like friendly fraud in a sense, but it is important because even though all these three categories roll up at the end of the day in a financial loss for someone, the intents are very different, and distinguishing different intents is what makes the whole difference when it comes to actually preventing it, and maybe on the other hand, facilitating some of the good behavior. So friendly fraud in this case is about people that do things in good faith and just forget. Right? Maybe you purchase something and next month you look at the bank statement and there's a transaction you don't recognize, you call your bank, and banks are pretty friendly to the users in a general sense, and they usually claim it on the merchant, right? So inadvertently, this user has done what he wanted, and the merchant has done what he wanted. Everybody operates in good faith here, but the end result is the merchant takes a hit. This is to distinguish from the other category, which is the actual malicious version of it, right? Like the other side of the coin, where instead there's people that do this for a living, and they try to hide in the mix, so to say. So it is important here to distinguish these two classifications, because you don't want to punish perfectly good users because you try to catch the bad guys. And you can see e-commerce right now is already a pretty old industry, and you can imagine that there's pretty standard techniques out there, which are all basically very reactive, right? They rely on observing some behavior, making deductions out of it, and reacting on what we've seen. So you might limit the source of origin of certain transactions. That's why sometimes you go abroad and your credit card doesn't work because someone has said, oh, if you travel this many miles in this much time, then it cannot be true. Right? You might limit the number of attempts. At the end of the day, though, all of this, since it's such a broad brush, it relies on screening manual transactions, because that's the only way you can actually distinguish false positives and false negatives. So 2017 by now, 2018 almost, obviously there's an opportunity in the market, right? And the opportunity is being exploited by a number of new operators that have come online over the last several years, that look at this problem from a slightly different angle, right? They look at the problem in terms of modeling behavior and modeling risk, and building associations between different user entities, and they try to make a prediction, right? Because at the end of the day, this is a prediction problem, right? And the sad part for me in this is that predictors have been pretty, they're not a new thing, right? We know how to predict things and how to predict predictors in different industries for several years now. And it's because of the conjunction with the fact that we can actually today run predictors on very large data sets that it has become the hype that I was saying it is at the beginning. And that was the age for me, right? So when you join a company and you see all of this and you see these opportunities that aren't being exploited, you say, why is that? It cannot just be because the technology isn't there, because the technology is there. It cannot be because people don't want to solve this problem, because there's obviously a gap and there's obviously a financial incentive in solving some of these issues. It turns out that there's basically two fundamental reasons that I could come up with, right? And the first one is that, as anybody else, people develop tunnel vision, right? So when they get focused on something and they start solving a problem in a certain way, that's what they do, right? They don't look besides and they look ahead. It's very hard sometimes to pull people out of this zone and make them realize what the actual context and possibilities are. The other reason is that there's usually a lack of understanding from a stakeholder perspective in terms of what it means to solve certain issues, not just from a technological perspective, but in terms of determining what the blast radius is going to be, right? And this is, I think, one of the key points here. because as a technology company ourselves, we're pretty good at reasoning on, bringing up that catalyst that, makes people realize why they have an issue, why they haven't exploited an opportunity. What we don't do a pretty good job at is instead solving the second issue that I just mentioned before, which is doing this in a way that is not so disruptive for both users, stakeholders, and ourselves in the first place. So there's a quote that I kind of started to paraphrase in a sense, which is about whatever you do, I'd like to do meta, right? And in this sense, it is true, right? That the meta problem here is how do we achieve potentially disruptive innovation in an environment that isn't ready for it or doesn't actually necessarily want it, right? And so I set off and kind of tried to correlate all these different examples that I could come up with into some ingredients that we can use to do this in a repeatable way, right? So in truth, I could have told you many other stories. I just picked on this one because I liked it the most. So what is that you need, right? What did you start, right? And it turns out that you can start from the easy stuff, which it might be vision is a very much bloated word nowadays. It can mean anything. There's a lot of books being written about what it means to have a vision and establishing a vision, all of that. In this case, it just means to how to make it so that people can be both excited about something, but also they can understand the implication of what that excitement is going to bring to the table. And to build a vision meaningfully, I think that you need to start from actually being able to reason on the problem space in a way that cuts through the possibility of going down rabbit trails, right? So if you abstract away the problem enough, then you cannot go and identify sub-optimizations because they're not apparent at this level. And for us, for example, the problem is pretty clear, right? The problem is, sometimes it can take months between the moment in time where some data points arrive in our systems and when we actually action something against them, right? Because they have to go through this cycle where data enters and people gain insight about what's meaning, and then eventually they might, these insights, they might require application changes, for example. So even in a pretty agile shop, such as we are, you have to jostle between priorities, and it's not easy, right? It's sad, but it's not easy, right? So you don't want this, right? So the problem is that we don't want that. We actually want this other incarnation of the same thing, which is doing it real time. And before you can actually look at the solution, you have to start with why, right? And the underlying reason for why this is relevant and why it was relevant back at a specific point in time is that you have to understand that at some point, certain things won't come with what you have, right? The catalyst that this problem we couldn't have solved with what we had, right? Our operators couldn't have solved this problem with what they had. They needed something different. And that's why it's important to reason on the context, right? And I'm using here a dumb metaphor about, you have a Swiss Army knife. It does many things. You might, use it for cutting a small branch, but if you have a bigger log, okay, you can try. Maybe eventually you get through it. But is it, are we doing the right thing here? And this is a metaphor that is quite important because it speaks of avoiding sub-optimizations, right? Because from a system perspective, any optimization that you bring outside the bottleneck is either an illusion or not really helpful, right? And in this case, the bottleneck is that we had tried to use not the wrong tool, but just too few tools to get too many jobs done, right? And you can imagine that one of the problems here is data layer that we had, the database technologies that we had. We do have, and operators have pretty sophisticated data warehousing solutions that might claim to be our real-time or whatnot. But fundamentally, they're all based on the same relational database technology that we've seen for many years. And the trouble with that is that we've learned how to bend these tools and these technologies so well that we've made them inflexible from one side, we've made them hard to read and write to and from with the slow. And this is what actually hinders our capacity to innovate, because when it comes to a point that you say that the decision is made that I want to build a predictor, how do I test a predictor if I don't have enough data points, if the data isn't rich enough for me to test the predictor in the first place? You have to first be able to get the data somewhere that you can then crawl and manipulate. And our tools back then just didn't allow that, right? Because they were used for too many reasons. So at this point you say, oh, we understand the context, we understand the underlying problem and reasons why it's relevant for us to discuss it. What is that you latch on? And you latch on a buzzword, right? That's, big data is, at the end of the day, just another buzzword, right? But it is helpful because it helps crystallizes in the imagination of not necessarily technical people concepts that might be wildly different, right? Big data from a technology standpoint, it means certain things. Big data from an operating model perspective, it means an entirely different thing. But at the same time, you can roll up all of this within the same umbrella. And this is very helpful when it comes to establishing a trust relationship with people that actually have to use this product at the end of the day. So is that everything there is, is this enough for us to be meaningfully articulating a vision around what it means to adopt big data solutions? Turns out that not really, right? You can't just, this would be what, anyone working in consulting here? No, okay, one. Sometimes you see, and it's not because, again, we operate in bad faith, it's because this is what we do, right? Sometimes we sell something without necessarily articulating what the implications are, right? And for us, being a technology company but not a consulting company, we do take this in a slightly different way. And the first reality check that you have to have before you can say, okay, now I'm done, I can start with something, is technology selection, right? And truth is that technology selection is getting increasingly difficult nowadays, right? So this is not even up to date, it was never accurate probably, but it just gives you an impression of how many solutions are there for arguably very consistent set of reasons, right? There's two reasons for that, because as technologists, we like to build stuff, right? And if something exists but doesn't entirely match our expectations, we build a new one. And that kind of fosters or reinforces the tendency for building new verticals, right? And that can be then marketed and sold from different vendors. The other point here is that to an extent, we can repeat the same activity we've done with the relational databases, in the sense that all these tools and all these database technologies or data layers, they can be bent in a sense, right? So I might as well build a document store out of the graph database, and I might as well build a time series database out of a columnar data store format. And there's a lot of PR being done around this, right? And it's not necessarily bad, as long as you're able to reason on what the consequences, not just in the short term, like for the first adoption, but what the consequences are going to be in the long term. So how do you navigate this map, right? I think there's three items that can help you go through it. One is having a big picture, and big picture doesn't need to mean a pretty diagram, but it needs to be something that highlights two things, right? It has to highlight what capabilities are needed to solve specific problems or to our specific pieces of value. And it has to highlight what decisions need to be made and when, right? This is crucial, because otherwise we just walk into this big unknown space with wishful thinking, basically, right? Without not really knowing exactly what we want to get out of it. These are the considerations that you need to make at this level, at this point, and we'll go through this more in depth later on. So let's not get focused on the diagram itself. The other considerations are: do we have the skills? Is the market providing those skills in those regions where they're going to be needed? Are the timelines matching? Right? How does it look from a learning perspective? We do operate in learning organizations for the most part, but learning has to be factored in when it comes to actually adopting something that you might be able to use for the next 3, 5, 7 years. The second step is reasoning on the complexity of this data, right? And it could be complexity of data, but it could be complexity of something else. Traditionally, complexity back when big data was coined as a term was regarded as to a size problem. We've gone past that, and there's a model now that is about the 5 V's, which is about the volume, so how much data you have. It's about the velocity, like how many data points per second do we need to ingest, for example, or manipulate. there's a question of veracity, like not all data sources are created equal when it comes to actually trusting what they mean. It's not, pulling data from a credit institution is very different than scraping social media, for example. So you want to deal with those differently. The fourth item here is variety, right? So you may have, it's very different to tackle one data source than tackling 50, especially if the format of the information is unstructured, it changes over time, we don't want knowing. Like all these factors, they contribute to the ultimate decision making when it comes to actually picking, in that big landscape. At the end of the day, you have to pick. And this is kind of what helps you understand, if something is needed, if something is overkill, if something that's not fit for purpose. There's value, of course. Value plus velocity and volume gives you an overview of, what data retention could be, for example, for different data sources. Low value, high velocity, I might keep for a day. High value, low velocity, I might keep for a year, right? And then there's extrinsic complexity. Extrinsic complexity is not just about the data per se, but about how we manage it from an operational perspective. And there can be many more boxes under this umbrella, but availability and confidentiality are two examples where, for example, do we need master-master replication every time? Do we need it just for specific subsets of these data streams? Do they need to be regionally available in a certain sense? Then there's confidentiality, for example. Can we assume that the data can live co-located even though there's different clients operating with it? So you see, this is just a mental framework to reason about, to navigate that map that we had in the beginning. And the third component about navigating the map is the experimentation part. Experimentation is key, right? Because going back to selecting things based on brochures, brochures, they don't mean to tell you everything, right? And you have to go through the due diligence process of understanding how they can actually be operated in production in a meaningful way. It means, understanding how the cap theorem works in practice. So, anyone not familiar with the cap theorem here? Okay, so in a sense, let's say that, cap theorem says that you cannot have it all, right? You cannot have a database that is fully consistent, 100% available, and that tolerates partition at the network level, right? So you have kind of make a compromise. And understanding what this compromise is what makes the whole difference between being the one that, shows at a party and is the soul of the party and the one that ruins the party, right? And as usual, the devil is in the details, and this experimentation layer is what we'll see has a fundamental contribution from DevOps culture and DevOps movement within any organization. There's very good tools about going for experimentation, there's Jepsen, and it is actually helpful because at the end of the day, you may have identified a set of technologies or products that are fitting perfectly what you need, but they're extremely complex to manage. And the question there is, do I really need this, right? Is it worth the investment, basically? Second reality check here is about people and skills, right? And I'm going to focus on two groups of people for many reasons. One is being concise. The first group of people is traditional BI towards data science, these kind of things, right? Our clients do have BI capabilities, right? And the challenge with that is that they are a reflection of having used, a very narrow tool set for many years, and their skill set shows, right? So they kind of match what kind of problems we ask them to solve. And even if you were to roll out a shiny new data platform that does all sorts of things and dump this on BI teams such as like this one, you cannot really expect that they get not the job done, but the job that you want them to do done, right? And that's because there's a mind shift in the middle, right? There's a mind shift in going from building reports and reacting on alerts to actually getting rid of those reports in the first place. That requires a change in skills, right? So you have to build a team that is skilled in a different way, and you want to leverage, yes, the strengths that the team might have, but you have to complement it with other things. So you have to, work on that plan as if it was any other development plan. But also you have to focus on building the actionable insights that you really want to get out of this, because otherwise you see all this value we might get out of a technology selection isn't really materialized anymore. Not because the technology doesn't deal with it, but because we don't know how to use it properly. So you really need to find someone that can champion these ideas from within. The Dunning-Kruger effect is about this relationship between confidence and mastery, and the relationship is basically a U-shaped curve, right? And it means that in the middle of this journey between going from newbie to expert in something, you're gonna hit a valley where you don't feel confident, and that's a threat to this program, because when people don't feel confident, they start complaining, and they might say, oh, actually this doesn't work, there's doubts being sparked around, and that doesn't help, right? When you have put a machine like this in motion, we have to be aware of these risks and deal with them. Second set of people is DevOps. I've sort of said that this is the only slide that mentioned DevOps, even though we're at a DevOps specific conference, because I felt that there's really no need for me to go deeper in any of this, right? And this part of the slide isn't reflective of what DevOps mean or what DevOps is meant to do, or there's been many other talks today, and there's many other talks that are available on the internet about DevOps specifically. For me, I have the luxury of working in an organization with a pretty mature DevOps culture, so I take this for granted in a sense, right? And I'm happy that finally we're getting to a point where DevOps as a culture, we almost take it for granted, right? It means that we finally get to a point where we don't regard software development as different silos anymore, where DevOps is just a collection of techniques that you plug into it, but it becomes an integral part of it. Like, this is modern software development, and DevOps is part of it. And one of the telling points in terms of understanding how well DevOps maps on some of the modern software development principles like Lean is that actually when you look at the house of Lean, it is pretty well aligned to it, right? You have stuff like continuous improvement. You have being able to adopt and own a production environment meaningfully. You have involvement with the team. So you can see that these two, you could call these 4 pillars of DevOps as a movement. They very well match to what we want to use as a set of principles and guidelines for modern software development and application development. The third maturity check the third reality check, is actually about maturity and innovation, right? Because it turns out that there's a very specific correlation between the state of maturity of an organization and product development. And there's 3 phases that have been identified and started in this model by Atterbeck. And there's a fluid phase where you're building a new product, and you focus on building innovation in the product before you actually start looking at optimizing the way you build the product. And at some point, a dominant design emerges. Think about the iPhone, right? There's a before and after. And when the dominant design emerges, then companies start to refine that dominant design, and things like product design or the canvas process or all these optimizations that happen at the process level come into place to supply for the diminishing returns in investing in innovation. And finally, you have a third phase, which is about optimizing cost, right? And the challenge for us is that we might be an organization that is at this point in terms of process innovation. So we've invested in building things in a repeatable way, but at the same time, we want to do this, right? So it's almost like trying to match these 2 offsetting curves, and because we want to reap the benefits of both, right? We want to be able to cut through some corners in terms of process for the sake of getting better benefits out of a different thing. So what is that we're missing at this point? This was basically the first ingredient, right? So building a vision and establishing trust and all of that. How do we take it from here? There's obviously something missing, right? It's not just because I am able to represent something in a diagram or in a slideshow that it magically happens. There's something else, right? The second ingredient for that is actually to focus on value, right? And value is unfortunately not a well understood language when it comes to discussing what's worth doing, right? And most of the times as technology companies, we get into this fallacy where we equal output to outcomes, and those are 2 very different things, right? So in terms of building a suite of products or services like this, you really want to, going back to that three-phase model, this is like an alternative interpretation of that, right? Any product has, a set of core benefits, and then there's stuff that sits on top of it, right? You want to ripe these benefits or the value out of these benefits as fast as possible, right? Because that's what allows you to actually establish trust and a proper conversation between you as a proponent of something or the trigger of a change and people that have to use this or have to live the results of this change. And also, it kind of avoids falling in this trap of building more because we like it, right? Every time we rebuild something that has been solved in the past, we have this tendency of doing more of it than necessary, right? So this is called biggerism, right? There's a very nice story about the Park lab where, one of the first, the very first computers were built, right? And there's this story about every generation that would pull up, it would be more complex, would cost more, harder to operate, but it was just better from an architectural perspective. And that's what we don't need, right? We don't need to build more complex architectures just for the sake of it, right? Just because it's cool. Okay. So the caveat here is that even though you were able to focus on these core benefits, it's hard to specify what those core benefits are, right? Those core benefits, they cannot be easily expressed in a sense sometimes. And the trap with this is that if you just set off with this, focused team that is going to build this awesome solution over a period of time, you cannot just pretend that you just set them off and then wait and expect that exactly the same results that you were expecting are going to be appearing at the end. It doesn't quite work like that, and we've seen this over and over. And this is not a problem with the way software or technology is built or developed. It is a problem with how we manage the expectations, right? The problem is that when this happens, because things will change, and we don't realize, then we end up in the blame game, right? And this is a bit of a sad story again, because these two actors, it's not that they want to cheat on each other. They actually, again, operate in good faith. It's just that the expectations weren't set in a meaningful way. So what do we do? What is the technique here to get rid of this? And the technique, obviously, is to learn from what you do at every step, right? And this is, again, this is not about agile development at all. This is about lean product management, actually, right? It means that we set off with something easy. When we get there, because of changes in the dynamics of where we operate and changes in the way we interpret those objectives in the first place, we're going to have hit something else. And the important part here is that from that something else, you iterate, right? And you learn from more recent and up-to-date information so that you can shoot for a better target. It might be that at the end of the day, you didn't really want to reach this point. You wanted to reach something somewhere in the middle. It doesn't really matter. It doesn't have to be perfect, doesn't have to be accurate, but you have to be able to have this process in place that allows you to go through planning something, doing it, and then checking on that and learning from that experience and moving on. And in this case, it means that, for example, if you want to pull in new data sources to see if they're variable, then focus on getting those early measurements and then experiment somewhere else. You don't need to involve a whole machinery for doing that. So anything missing, right? So we've gone through reasoning on the problem, building a vision. We know that we have to focus on value first. What is that we do after this, right? Is that everything there is? Can we just rely on product managers to solve all these problems for us as an engineering group? Turns out that the third component is actually managing expectations properly, right? And managing expectations, again, is a squishy term, right? Because you see, progress could be defined as how far we are from an arbitrary target. It could be about how much stuff we've done. And this is actually what the problem is, because traditionally, we can come up with, burn down charts and whatnot that tells us, how far we are from a target. But you see, in this process, we've introduced a proxy variable. And the proxy variable is something that, is correlated to the original measurement you want to take, which is, in this case, is the flow of value, but is measured in different terms, right? It's measured out of observations that you make. And in this case, the threat here is that if you make observations about, for example, something like velocity, right? Velocity, you could say, is the amount of stuff that I get done by some arbitrary measure, like points, complexity points maybe, over time. That is very different from value over time. right? And if these two things don't relate to one each other, then we end up in the blame game that we saw before. So there's a difference, and we have to be aware of this difference between real and artificial progress, because you see, every time that you introduce a metric, every metric can be gamed if the right incentives aren't applied. And if you're applying the wrong incentives, then you might end up with something like this, right? This is actually a real example, right? So you have little project, and there's defects created over fixed. You see that at the beginning here, everything goes fine, every defect that we create, we also solve. And then something happens, and they kind of blast off, right? The problem with this is that we could mark these features as done, and we acknowledge that they're done, but there's defects. So is this really real progress, or is it going to be coming after us in the future? Before we look at that, let's look at two techniques that I think are useful to actually reason on honest progress. So, establishing a conversation that isn't about how fast we go, but it's about how well we are doing. The first part is about automation, right? And automation is an integral part of honest progress because it cuts through handoffs, and it cuts through the uncertainty about where something is standing, right? And there's two types of automation. So, sorry, if someone can tell me what they think happened between these two lines, bonus points. Anyone? What happened in the middle? You can tell me at the end. So the first part is testing, right? And this is, again, not an agile conference. We're not here to discuss agile testing per se, but it's important to understand that testing and QA automation are key to the flow of value, right? If automation is not efficient, you might as well not do it, right? You might as well not bother. The reason for that is that you definitely don't want to end up in a situation where you invest all this time and you promote testing and automation of the testing, and then people start complaining about, oh, the build is broken every time. That's worst situation you can ever be, right? So there's something that is called the test pyramid, concept introduced by Martin Fowler years back. This is our incarnation of a test pyramid, right? And the test pyramid basically means that you should really try to optimize the ratio between the value you get out of this automation suite and the cost of not just writing it, but maintaining it over time. So it basically says that, yes, end-to-end test that, test the UI and go through the whole, microservices architecture and test everything on real data. They might be valuable for certain things that actually they might have more value than a unit test, but it turns out that unit tests are far more manageable over time, right? So the truth is that most of your testing efforts should be concentrated at the bottom, right? And over time, we've seen different techniques that allow us to manage complexity at the test level meaningfully, but also create some additional value. And a good concept, for example, a good example is contract testing, right? Contract testing we do throughout the Splunk Cloud tool suite, for example, and it allows basically to, from one side, generate a unit test that represents a contract between two services, and on the other end, to generate a stub that, a component test on the consumer level can actually use for ensuring that the contract is still maintained, right? So out of this automation suite, you get for free that, if a contract between two services changes, you're automatically notified, assuming that you've modified the contract as well. All of this also hinges on the fact that not all of this test pyramid is executed at the same time. Most of this is executed before you actually build as a pre-commit hook, for example. And a part of that instead relies on an environment. And that's where we have to be careful when it comes to the second part of this, because you see, efficient QA automation doesn't only provide a shorter feedback loop to developers so that they're empowered to do their own testing on their local machines, but it also supports and enables continuous deployment. And there's been various talks, and there's going to be a keynote after this about continuous deployment, but this is our version of continuous deployment, right? We do continuous deployment for all our services right now, and we do it because we do automation this way. We do it in a specific way because, again, this is another example where we haven't just set off and built something from A to Z. We just incrementally addressed what the bottleneck was, right? We can go through this quickly if you want. Like, there's a set of services here, or microservices, where we fetch the code, we compile it. All of this is the underlying engine here is Bamboo plus a bespoke build administration tool that we built. But basically, we We check out code, we build it, we publish metrics around code coverage, ACOCO, whatnot, and Sonar. We have a data store that basically keeps track of all these metrics, logs, test results. And then we have the whole deployment pipeline here, right? So we do use different environments, all based on Kubernetes. We do run our own, so to say, private cloud in a sense. So we've abstracted all of these away. So at this point, the build pipeline is just about pulling a set of release specs that define what versions need to be deployed in which environment because of which push or commit let's say git commit, not git push. But basically, we are able to serialize every commit into a build pipeline, right? What this gives us is that in roughly, this doesn't fit in the screen, but roughly 20 minutes we can have a change shipped to production automatically, right? We have some manual gate at the end here that allows us to distinguish between changes that are in continuous delivery, which require manual approval, for example, because of some risk assessment we've made, and some other changes instead that just go through production, as in approval continuous deployment pipeline. This is not perfect, right? So if you compare this with Google, I think there were some benchmarks about Google being able to do this in 400 milliseconds or so, right? We're far from it, right? And we don't claim for this to be perfect. It's just that it's a stepping stone, right? One of the biggest gaps right now is that, for example, Bamboo doesn't do incremental builds, right? So without incremental builds, it's very hard to build one piece of change plus associated dependencies, which is what this step does, and then ship it across a number of environments. So running over, we have some goodies here, deployment tracking, so every change can be tracked across environments. We have some nice wallboards. And then I think I want to have the time of, I think I should have more time actually, but anyway. The second step was about waste, and waste is about getting things done. Sometimes you start seeing that even though velocity increases, the stuff that is done is actually less, and you have to understand why. It's not going to get better by itself. You have to just take a closer look. And usually the proper look means that sometimes you think you're doing all feature development and instead all sorts of unplanned work comes to it. And unplanned work materializes for different reasons. The main one being that you've created accidental complexity here, right? And accidental complexity is not painted that today will increase the ongoing maintenance, but like you're taking a cut on the long-term return of investment you just made. And so it's important to actually explicitly factor those types of work sources in, right? So exploration or refactoring are an integral part of what we do today. And then you have to manage the true unplanned work meaningfully. All this to say, end of the story, that this is not really about how we manage this single problem, right? I could tell you what the problem was and how we solved it for our specific e-commerce fraud example. We just ended up building a simple classifier based on a relationship that we store in a graph database that associate users with different data points. And these classifiers, they help us identify re-identification and bonus abuse, for example, things like that. The outcomes aren't really in the technologies we ended up using, right, which is also relevant, but for me, it's mostly about this, right, that you want to prove something, then engineer it, that machine learning can be done in Excel if you want to, and actually is useful because you don't have to put up all this engineering machinery to prove that the model doesn't work, for example. But also, it's about reducing clutter, right, and the fact that you have really to improve the way by not adopting something, you actually help not going down different rabbit trails. The lesson learned is that you have just to follow this 3-step process where, discuss on the problem in the context, you project a vision and you experiment and you start with why, and then finally, you just execute in a way that leaves room for continuous improvement and continuous learning throughout these plan, do, check, act life cycles. Questions? Oh, by the way, we're hiring. That's the only sales pitch I had to do. If I did too fast, then can't see me afterwards.
No questions?
Sorry if I sped up a bit at the end.
Yeah. Go for it.
How can you handle external complexity to a project? For example, in big data, you are using some external open source software, Hadoop or Spark or stuff. And sometimes you get bug in this, or sometimes you get feature, and it's external to your team, and
Mhm.
it's difficult to manage some design. For example, you want to do something, but you can't do this because you have no feature
Yeah.
in the version, and that can stop all your development. And what is
The bad part is when you realize that something is missing after you started, no? But that is, in a sense, it's part of technology selection, like doing your homework so that you can meaningfully identify what those gaps might be. Sometimes, though, you just have to deal with it. And for example, right now we have some gaps in the way we use Angular 2, for example. One way we try to use is to, pull up pull requests and contribute to these projects. Some other times we just suck it up, right? And
yeah, but it's common problem for working when you are working with open source. Then you have to invest all the time, again and again, in some project you are using. And without this, your pull request just stay.
Let's say traditionally we used to an approach where we invest in the pull request and then we hack our way around it, and that's what contributes to accidental complexity at the end of the day. Unfortunately, living by this open source project, which as you say you don't control the dynamics of, forces you to do that sometimes, right? Especially when they happen further than you expected. So I mean, we don't have a. If I had a clear solution to that problem, be a different story. Yes.
Could you expand a little bit on the methodologies to measure value?
Yes. Do we have to do this? Do we have time to do this now, or are we?
Like a couple of minutes.
Okay. There's different methodologies. For example, if you look at SAFe as Scale Agile framework, for example, they do a pretty good job of reasoning on how to measure value. The thing is, it doesn't really need to be accurate as long as, from a stakeholder and engineering perspective, you're able to agree on what value means, right? So for us, for example, we're happy to use value from 1 to 10, right? And if someone says that this has 10 of value and it cost is 3, then we're gonna do that first, or we're gonna prefer doing that over something that provides 12 of value and cost is 8, right? Because the ratio is different. So it doesn't need to be a dollar figure, right? But we have to establish that relationship in terms of, we trust you that you tell me what the real value is going to be, right? Because we are in the same boat at the end of the day. So the methodology is about stakeholder education, basically. We can be more specific afterwards if you want.
Thank you very much. We're unfortunately out of time, but we started from 4 o'clock. We're having open discussion here, so you can join Francesco if Francesco would like to join
Sure,
us.
of course.
And discuss whatever you want.
Thank you.